Hi guys, welcome to the next lesson on relative molecular mass. In this lesson, we're going to be looking at what is relative molecular mass and how do we calculate it. And this fits under Unit 1, Area Study 1D.3 for the calculation of the molar mass of ionic compounds. So some molecules, they exist as molecular compounds, and that can be oxygen, it could be nitrogen, or it could even be an ionic compound like sodium chloride, which we've seen before. The relative molecular mass, or MR, is equal to the sum of the relative atomic masses of that particular element or compound. So we've got multiple atomic masses. For example, let's take the compound carbon monoxide. We have a carbon molecule and we also have an oxygen molecule, one of each. So we know the individual atomic masses of those particular elements based on the periodic table, because we've known that the periodic table is a collection of all of the relative atomic masses of those elements. So if we look at carbon, it has a relative atomic mass of 12, as shown here. And if you look at oxygen, its relative atomic mass is 16, or 15.999, depending on the periodic table that you use. So if we add those relative atomic masses together of that particular compound, or molecular compound, or whatever we have, we are going to then have the relative molecular mass here. So if we add the mass of oxygen, which is 16, and the mass of carbon, which is 12, we're going to be given 28. So our molecular mass, or our relative molecular mass, is equal to 28. If you were to do something a bit more complex, such as carbon dioxide, we have to therefore account for the number of atoms of oxygen and number of atoms of carbon. So again, we find the relative atomic mass of carbon on this periodic table, it's 12, and then the relative atomic mass of oxygen, again, 16. We have one carbon atom and two oxygen atoms. So to calculate the relative molecular mass, we must sum all of the atomic masses of all atoms in this particular compound. So we have one carbon atom, two oxygen atoms, therefore we have 12 atomic mass of carbon and 2 times 16, or 32, for the atomic mass of oxygen. Sum those together and our relative molecular mass is now 44. So we have added all of the compounds, all of the atoms together to give our relative molecular mass of 44. Additional example of this, if you have an ionic compound, you've got magnesium, you have hydroxide here, so oxygen and hydrogen. To calculate that, again, you go back to the periodic table and you find that magnesium has an atomic mass of 24.3 and oxygen has a relative atomic mass of 16 and hydrogen 1. We have one magnesium atom, two oxygen atoms, and two hydrogen atoms, because this subscript 2 here applies to the whole bracket. Therefore, if we add all of the relative atomic masses together, we will receive our relative molecular mass of 58.3. Summary of this lesson is that relative molecular mass refers to the mass in grams of all elements based on their atomic mass values in the periodic table. And you should be able to understand what relative molecular mass is and calculate it when you're given a particular compound. These are the questions to complete for this lesson. Thanks for watching.